Algebra 2 Fall Semester Exam Review. So this is the review for Unit 1 of the semester exam. So Unit 1 is solving systems of equations and inequalities. So you did learn how to solve these by hand. However, I highly suggest you follow your calculator steps when solving these equations because the by hand method does take quite a bit of time and you do only have 2 hours for this semester exam. So we're going to review how to use our calculator. So for number 1, what is the solution to the system of equations below? So the first thing we need to do is put this into a matrix. So remember that a matrix has only the coefficients of each equation. So we have 4, -4, 4, and -4 for the first equation. We have 4, 1, -3, 5 for the second equation, and -3, -3, -4, -16 for the second equation. So these are all the coefficients for the r's, these are all the coefficients for the s's, these are all the coefficients for t's, and this is the number after the equal sign. So now that we have the matrix set up, we're going to use our calculator to help us out. And so here are your steps. So step 1 says second matrix edit. So we're second matrix, and then we're going to go over to edit and press enter. Now, what kind of matrix do you have? So this is a 3 by 4 matrix because there are 3 rows and 4 columns. So we're going to put 3, enter, 4, enter, and then now we're going to place all of our numbers into this matrix. So 4, and pressing enter after each number will move your cursor to the right. And then once you run out of space on the first row, it automatically puts you on the second row. So 4, 1, -3, 5. And -3, -3, -4, and -16. Enter. Once you have all of your numbers, you're going to do second quit. That's step number 3. Step number 4 says second matrix math and then the RREF. So second matrix math and then RREF. We have to tell the calculator what to do. And then now we have to tell it which matrix it wants to do this on. And so second matrix and names. Second matrix names. And then we're going to choose letter A, which is the place that we put our matrix into. Once you're here, simply press enter. And so this is the resulting matrix that you get from your calculator. So I'm going to go ahead and write it down for notes purposes. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a 1.15, this is 3.02, and this is 0.87. So what this says this says that your R is equal to 1.15, and your S is equal to 3.02, and your T is equal to 0.87. So you can write it out this way, or more commonly is we write it out in a coordinate point, RST, so in alphabetical order. So this is the solution to this system of equations. Now you have a practice on your own for number 2, and there is a place inside of Schoology for you to submit your answer to see if you've gotten it correct or incorrect. So let's move on to number 3. 3, 4, and 5 are word problems. They're solving systems of equations from a word problem, so you actually have to set up the equation yourself. So for number 3, Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? So first, we need to define our variables. Since it doesn't tell us what variables to use, we need to make them up ourselves. So how many of each type of flower was ordered, that tells us what our variables are going to be. So X, Y, and Z are going to all be the number of a certain type of flower. How many did we order? So we're just going to call X the number of carnations. That's one type of flower. We'll call Y the number of roses, and we'll call Z the number of daisies. And now the first thing I like to look for is totals of things. And so the first total that we come across is the fact that we ordered 200 flowers. Well, 200 flowers has nothing to do with a value. It's just the number of flowers ordered. And so to create the equation for this, we're going to add up the number of carnations plus the number of roses plus the number of daisies to give us 200 flowers. So the number of carnations is just X. So this is just X plus the number of roses is Y, so Y, plus the number of daisies is Z. All those numbers added together should equal to a total of 200 flowers. The second total that we have in this problem is the order. So the total order came to $589.50. This is where the value comes in. So not only do I care about the number of flowers, I also care about their total value. And so for the carnations, those were each $1.50. Carnations were each $1.50. So we're going to actually have 1.50 times the number of carnations we ordered. We also are going to add up the cost for roses. Roses were $5.75 each. So plus 5.75y, plus the daisies were $2.60 each. So plus 2.60z. All of that should add up to a total of $589.50. And then the last equation is this one here that compares roses and daisies. There are 20 fewer roses than there are daisies. So fewer means we're going to subtract. And what this comes out to is how you find the roses is roses are the daisies minus 20. So roses are equal to the number of daisies you buy minus 20. That's how you write 20 fewer roses than daisies in a math equation. So this is the written out system of equations that represents this situation. Now solving this, you have to put this into a matrix. Well, the first two are fine the way they are. And so the middle one will be 1.5, 5.75, 2.6, and 589.5. We don't need the zeros on the ends. The top one, 1, 1, 1, 200. The third one, you're going to have to manipulate a little bit. I need all of my variables on one side and all of the constants on the other. So we're actually going to have to move this z over to manipulate it just a little bit. So it's going to be y minus z equals negative 20. So these are all of your x's, these are your y's, these are your z's. And so when we put this into the matrix, it's actually 0x, then 1y, negative 1z, and negative 20. So this is what we're going to end up putting into the calculator ourselves. So I'm going to, again, do second matrix, and I'm just going to use the same letter A. I'm going to use letter A. I'm going to edit letter A. It's still a 3 by 4, and I'm going to type in my new numbers. 1, 1, 1, 200, 1.5, 5.75, 2.6, 589.5. And then 0, 1, negative 1, and negative 20. Now that we're here, we're going to do second, quit, go back into the matrix, and then we're going to choose math and do RREF, and then tell it which one to do that on. Second matrix, and we're going to do A again, and press enter. And so what we have then is now we have, so this is our answer, so this comes into 10080, 01050, and 00170. And so what this means is that your carnations, you had 80 of them, you had 50 roses, and you had 70 daisies. Because of the way we defined X, Y, and Z. These are your X's, your Y's, your Z's. So you guys are actually going to try number 4 on your own. So I'm going to skip down to number 5, and let's set up number 5. I'm going to have you solve it by yourself, but I'm just going to set up number 5 with you. So you have 88 coins consisting of quarters, nickels, and pennies. The value of the coins is $6.36. There are twice as many pennies as nickels. Write a system of equations that can be used to represent the situation where Q is the number of quarters, N is the number of nickels, and P is the number of pennies. Then solve it to find the number of each type of coin. And so they gave you your variables this time. So Q is number of quarters, N is the number of nickels, and P is the number of pennies. So again, start just like we did before, look for totals. And so I first have a total of 88 coins. Well, I don't care about their value. It's just going to be the number of quarters plus the number of nickels plus the number of pennies will add up to be 88 coins. Then I also know that the total value of the coins is $6.36. So this is where their value comes in. Well, a quarter is worth 25 cents. So 25 cents in a decimal is 0.25 times the number of quarters plus nickels are 5 cents, so 0.05 times the number of nickels, and pennies are 1 cent, so plus 0.01 times the number of pennies. That should add up to a total value of $6.36. And the last equation comes from comparing, and so this says that there are twice as many pennies as there are nickels. And so the way that we find the pennies is we're going to take 2 and multiply it to the number of nickels. So this is the system of equations that represents this situation. So solve this on your own. Now for number 6, systems of inequalities. So write the inequalities that show the solution set graphed below, then state if the given coordinates are solutions to this system or not. So think back to Algebra 1. So the easiest way to write a line is y equals mx plus b. And so I'm going to pick one of these lines on this graph. I'm going to pick, let's say, this one. And I'm going to write the equation for that first line. So that means I need the y-intercept and I need the slope. So the y-intercept is really simple. Find where it crosses the y-axis at 1. And so for the slope, I'm going to pick another point, which is here, and I'm going to find rise over run. So the rise is very simple because these are going up by ones. So 1, 2, 3, a rise of 3, but the run is actually only 1. If you look at your scale, this is actually at 0.5. And so 2 blocks is actually 1. And so my slope will be a rise of 3 and a run of 1, so it makes a slope of 3. So when you write your inequality, you're going to have y, you're going to skip a spot because you're going to have one of those less than, greater than symbols, m of 3x, and then plus b. Now let's figure out which symbol we need. And so less than or greater thans, those both give you dashed lines. The less than or equal to, greater than or equal to, those give you solid lines. So on number 1, I actually have a solid line here. So it's going to be one of these symbols here, less than or equal to or greater than or equal to. Then to figure out which one, we need to look at shading. And so the less thans will shade below your line, and the greater thans will shade above your line. And so if I look at my y-intercept and I draw an arrow towards the shade, I'm shading above this line. So that means it has to be a greater than or equal to symbol. So this is one of the inequalities on this graph. And so if I look at my choices, letter A, it's right here. Letter B, it's here. And then C and D, there isn't a y greater than or equal to 3x plus 1. So C and D are not correct because it's missing one of the inequalities. So now we're going to do this process one more time with another line. So let's choose maybe the second one. Let's choose this guy. So for number 2, you're going to follow the same general process. Find the y-intercept. So in this case, the y-intercept is at 4. And then we're going to find slope again. So pick another good point, which is one right here, and find rise and run. So it's a rise of 1 and a run of, remember, each 2 is a single unit. So this is 1, 2, 3. So I have a run of 3. So 1 over 3 is my slope. So we've got y, some symbol, 1/3 x plus 4. Now let's figure out which symbol. So it's a dashed line, so it needs to be one of these symbols, less than or greater than. And then where am I shading? Well, if I find the y-intercept and I draw an arrow towards the shade, this is shading underneath the line, so below the line. So it needs to be a less than. So my equation, or my inequality, is y less than 1/3 x plus 4, which is here, and letter B actually does not include this, so letter A is the correct choice. You didn't even need the equation for this third line. I got to the correct answer by only creating 2 of them. Now for the second part of the question, it said, which one of these coordinates are solutions? So I'm going to erase my colorings for the creation of the lines themselves. So for the second piece, we're going to plot points and see if it lands either in the shade or on a solid line. So 2, 2. 2, 2 is actually here. And so since 2, 2 is not in the shade, this is not a solution. So for 0, 4, 0, 4 is here on a dashed line. That is not a solution. We cannot include dashed lines. Dashed lines are not solutions. Not solutions. Now, -1, 2 is on a solid line. That is a solution. Solid lines are solutions. Solid lines are solutions. And then for negative 1.5, 3.5, negative 1.5, 3.5, this is actually a no as well. And the reason why it's a no is because, yes, it falls on a solid, but it also falls on a dashed. And once it falls on any dashed line, it is no longer a solution. So that's why this is a no. So you guys are going to try number 7 on your own. Number 8. So Tony works at a taco shop and makes $9 an hour and walks dogs and makes $7 an hour. Tony wants to work no more than 16 hours a week and wants to make more than $115 per week. Write a system of inequalities that could be used to determine the number of hours Tony can work at each job. So this is where you're writing another system, but instead of an equal sign, it's going to have an inequality. So the number of hours that Tony works at each job. So that's your variables. So let's call X the number of hours at the taco shop. And let's call Y the number of hours at walking the dogs. And so again, we're going to start this the same way we did earlier. Look for totals. So I see that he wants to work no more than 16 hours a week. So that's a total. Well, 16 hours has nothing to do with money. So this is simply the number of hours at the taco shop plus the number of hours walking dogs. Now, no more than, that's going to be a less than or equal to. He wants to work basically 16 hours or less, not higher than 16. And I would look for another total, and I see that there's another total here. He wants to make more than $115. Now we have the value, the money that comes into this. And so at his taco shop, he makes $9 an hour. So 9 times the number of hours gives you the value of money. Plus his dog walking, he makes 7. So $7 times the number of hours he's working should be more than 115. Now it's not equal to, he wants over 115, not exactly that much. And so this is all we have for the system of inequalities for number 8. So you guys are going to try number 9. Now for number 10, determine if the given points are solutions. And here we have another system of inequalities, but it's not a graph, it's just equations or just inequalities. So we have to do this algebraically. So what we're going to do is we're going to substitute these values of x and y and see which one makes all equations true. So solutions make all equations true. Not just one, not just two, it has to be all of them. And so for letter A, I'm going to start off with the first one. And so for number 1, it says y less than. So y is a 0 less than 3 times x, which is also 0, minus 4. And we're going to simplify this. So 3 times 0 is 0, and 0 minus 4 makes negative 4. Now, is 0 less than negative 4? And this is a no. This is false. This is no. This is false. So since we already came across something that was false, something that was not true, we can go ahead and say that letter A is not a solution to this system of inequalities because it has to be true for everything. And now we can move on to letter B. So for letter B, we're going to start off again with number 1. Here's x, here's y. We're going to plug them in. So y should be a 2, so 2 less than 3 times x is a 3 minus 4. We're going to see if this is true. 3 times 3 makes 9. 9 minus 4 makes 5. So is 2 less than 5? Yes. So since this is true, we're going to check the second equation. We're going to check this guy. And so we have x less than or equal to 5. Well, x is a 3, so is 3 less than or equal to 5? Well, there's no math involved. This is already simplified. And so yes, 3 is less than or equal to 5. So since the second one was true, we also have to check the third one. So y greater than negative 2. Well, y is a 2. Is 2 greater than negative 2? Yes. And so since this is true for all 3, we can say that yes, letter B is a solution. So now let's try letter C. So for letter C, number 1, here's x, here's y. So y less than, so negative 2 less than 3 times 1 minus 4. So negative 2 less, 3 times 1 makes 3, minus 4. Negative 2 less than negative 1. Well, is negative 2 less than negative 1? Why, yes, it is. So far we're okay. Let's check the second one. Is x less than or equal to 5? So 1 less than or equal to 5. That's true as well. And now we check the third one. Y greater than negative 2. Negative 2 greater than negative 2. Well, that's false. Negative 2 is not greater than itself. Negative 2 is equal to itself. And so since we came across something that was false, this is not a solution. And now we try the last one, letter D. So for letter D, check number 1. X is 5, y is 11. So we've got y, which is 11, less than 3 times 5 minus 4. 11 less than 3 times 5 makes 15. And 15 minus 4 makes 11. And similarly, 11 is not less than itself. So this is also false. So that means that letter D is also not a solution. So take your coordinates and plug them into each inequality and make sure you get something that is true for all inequalities here. So you guys are going to try number 11 on your own. Let's look at 12. So how many solutions will there be for each system of inequalities shown below? Well, for it to be a solution, I need all 3 planes to share at least one coordinate. And so if I look at this first picture, I look at this little intersection up here. So this intersection has only blue and green. It's missing the red one. So far, no solution. This one here has blue and red, but it's missing green. So again, so far, there is no coordinate that all 3 share. And then finally here has green and red, but not the blue one. So even here, there is no point that all of them share. So since these have no points in common, this is a system that has no solution. There is no coordinate that will eventually make all equations true. If we look at number 12, the second one for number 12, it crosses on this line here. And so this coordinate has all 3 planes, this coordinate's on all 3 planes, so is this one, so is this one. So this has lots of answers. So this is your infinite solution. There's an infinite number of coordinates that lie on all 3 planes. And so there's not just one answer, there's an infinite number of possibilities. And then for the last picture, we have this single coordinate of intersection. So this one little orange point is the only coordinate that lies on all 3 planes. And so this is where you have the one solution. So it needs to be on all 3 pictured planes for it to be a solution.